Right now, the farthest human-made object ever built is drifting through space at over 60,000 kilometers per hour. Voyager 1 has been flying for nearly 50 years. It has crossed the edge of the solar wind, punched through the boundary where our sun's breath fades to nothing, and entered interstellar space. It is roughly 170 astronomical units from home, and it has not even begun to reach the Oort Cloud. The inner edge of that invisible shell sits more than 2,000 astronomical units away. The outer edge might stretch past 100,000. If Voyager 1 were a car pulling out of your driveway, it hasn't yet reached the end of your street. And the Oort Cloud is on another continent. If you enjoy journeys that stretch the mind past anything comfortable, do me a small favor and hit that like button. And if you haven't already, subscribe so you don't miss what comes next. Now, get yourself comfortable. Let's begin. Open any astronomy textbook. Find the diagram of the solar system. There it is. A clean illustration with 8 planets arranged in neat concentric orbits around a yellow star. Mercury closest, then Venus, Earth, Mars. A stippled band for the asteroid belt. Jupiter, Saturn, Uranus, Neptune. Maybe Pluto appears as a small dot at the far edge with a dashed orbit, and a footnote explaining its reclassification. The whole arrangement fits perfectly on a single page. The labels are tidy. The distances look manageable. You can trace the entire solar system with your fingertip in about 2 seconds. That diagram is a lie. It's not just slightly off. It's not just rounded up for convenience. It is wrong by a factor so extreme that calling it an oversimplification doesn't even come close. If you corrected that classroom image to true scale, the 8 planets would collapse into a space so small you couldn't print it. The entire zone from Mercury out to Neptune, every world you have ever been taught about, every rocky surface, every gas giant, every ring system, every moon, occupies less than 0.1% of the sun's actual gravitational territory. Everything beyond that thin planetary ribbon belongs to a solar system you were never shown. A solar system that is darker, emptier, and so vast that the familiar planetary neighborhood shrinks to a pinprick at the center of something almost incomprehensibly large. Let's start with what we know for certain. Neptune orbits the Sun at an average distance of about 30 astronomical units. 1 astronomical unit, or AU, is the distance from Earth to the Sun, roughly 150 million kilometers. So, Neptune sits 30 times farther from the Sun than Earth does. That distance is impressive by everyday standards. Light from the Sun takes about 4 hours to reach Neptune. A spacecraft traveling at Voyager's blistering speed would need over 12 years just to arrive. For most of human history, Neptune marked the outermost boundary of the known solar system. And honestly, that seemed like enough. When astronomers discovered Neptune in 1846, they believed they had found the frontier. For over a century afterward, the map expanded only slightly with the discovery of Pluto in 1930. Pluto sat at the edge of the map, a tiny frozen dot, and for a long time, humanity assumed the solar system ended right there. Except it didn't. The planetary solar system is not the actual solar system. It is just the brightly lit lobby of an unimaginably vast, dark building. And to understand what lies beyond that lobby, we have to look at the wreckage left behind. To understand the scale of what we are dealing with, we have to look at the first layer of that wreckage, the immediate suburbs. For decades, Pluto was the ultimate misfit. It had a weird tilted orbit. It crossed Neptune's path. It was tiny, smaller than our own moon. It simply didn't belong with the majestic gas giants. Back in the 1950s, astronomer Gerard Kuiper suggested that maybe Pluto wasn't an anomaly at all. Maybe it was just the brightest, most visible object in a massive belt of frozen debris left over from the formation of the planets. It took 40 years of technological advancement to prove him right. In 1992, astronomers finally spotted another dim object beyond Neptune, then another, then hundreds more. This avalanche of discoveries revealed the Kuiper Belt, a massive, donut-shaped ring of icy bodies stretching from 30 to 50 astronomical units from the Sun. When NASA's New Horizons spacecraft finally reached Pluto in 2015, it silenced anyone who thought the outer solar system was boring. It didn't find a dead, cratered rock. It found a complex, geologically active world. There were flowing nitrogen glaciers, towering mountains of solid water ice, rising as high as the Rockies on Earth. A blue, hazy atmosphere backlit by the distant sun. 4 years later, the probe flew past Arakoth, a pristine, reddish, snowman-shaped rock that has sat in a cosmic deep freeze, entirely undisturbed for 4.5 billion years. But the Kuiper Belt is just the front porch. And it doesn't end with a clean boundary. It frays outward into something far more violent. To understand why, you have to realize that the orderly, clockwork solar system you see today is an illusion. It is the aftermath of a catastrophe. In its infancy, the solar system was packed tightly. Jupiter, Saturn, Uranus, and Neptune orbited much closer to the Sun than they do now, surrounded by a dense, heavy disk of icy debris. For millions of years, this arrangement was relatively stable. Then, Jupiter and Saturn hit a gravitational tripwire. They crossed an orbital resonance, meaning every time Saturn completed one orbit, massive Jupiter completed exactly two. Their combined gravity pulsed in rhythm, pumping enormous, destabilizing energy into the outer solar system. The whole structure broke down. In a geologically brief window, the giant planets scattered like billiard balls. Saturn pushed outward. Uranus and Neptune were hurled into wider orbits. Neptune, massive and unstoppable, plowed directly into that pristine ring of icy debris, like a wrecking ball into a brick wall. The gravitational violence of that moment is hard to overstate. Neptune swept through trillions of frozen objects, grabbing them with its gravity and hurling them in every direction. Some were thrown inward, causing a devastating meteor bombardment that scarred the early Earth and Moon. Countless others were ejected from the solar system entirely, banished to the interstellar void. But a massive fraction of that debris was thrown outward onto wild, elongated, highly tilted orbits. These barely bound survivors carry the permanent, chaotic signature of that ancient disaster. We call this region the scattered disk. The scattered disk overlaps with the outer edges of the Kuiper Belt, but it pushes the frontier much, much farther. The most extreme objects in this scattered population have orbits that carry them hundreds of astronomical units from the Sun. That alone is enough to shatter the textbook map. We are already talking about distances tens of times farther than Pluto. But the true shock isn't the suburbs. It is what happens after the suburbs end. Because beyond the scattered disk, there is a gap, a vast, dark, seemingly empty chasm between the known worlds and whatever lies waiting in the dark. Let's talk about that gap, from roughly 1,000 astronomical units out to perhaps 2,000 or more. There is a desert. No confirmed objects populate it. No telescope has surveyed it comprehensively. It is a staggering chasm between the outer fringes of the scattered disk and the beginning of the Oort Cloud. Try to picture what this gap contains. Nothing that we know of. No icy bodies large enough to detect. No scattered debris returning from distant orbits. Just space. Cold, empty, featureless space, stretching outward for hundreds of billions of kilometers without a single landmark. Out here, the Sun has entirely lost the appearance of a disk. It is just a point of light. Brilliant. Yes, but small. It offers absolutely no warmth and precious little illumination. An object drifting through this gap would be bathed in near total darkness, lit only by starlight and the faint residual microwave glow of the Big Bang itself. At Voyager 1's blistering speed, crossing this gap alone would take centuries. But it's what astronomers found. just before and inside the edges of this gap that truly broke the models. In 2003, astronomers Michael Brown, Chad Trujillo, and David Rabinowitz discovered a distant object that defied every existing category. They named it Sedna, after the Inuit goddess of the sea. Sedna's orbit was unlike anything ever observed. Its perihelion, the closest it ever comes to the Sun, is approximately 76 astronomical units. Why is that a big deal? Because Neptune orbits at 30 astronomical units. Even the most extreme scattered disk objects pass close enough to Neptune during part of their orbits to feel its gravitational pull. Sedna does not. It is gravitationally detached from every known planet. Neptune cannot touch it. At the same time, Sedna swings out to nearly 1,000 astronomical units, placing it in a strange orbital no man's land. It is too distant to be part of the scattered disk, but too close to the Sun to belong to the classical Oort cloud. Sedna shouldn't exist where it does. Nothing could have formed out there, and no known planet could have pushed it there. And Sedna is not alone. In 2014, astronomers found 2012 VP-113, another detached object with an orbit totally isolated from the giant planets. Then, in 2018, came the discovery of 2015 TG-387, informally nicknamed the Goblin. The Goblin is a ghost of a world. Its closest approach sits at 65 astronomical units, but its orbit stretches out past 1,100 astronomical units. It takes roughly 40,000 years for the Goblin to complete a single orbit around the Sun. For the overwhelming majority of that time, it drifts in total darkness, so far beyond the reach of human telescopes that it is entirely invisible. It spends almost its entire existence as an undetectable phantom. Astronomers only found the Goblin because it happened to be passing through that incredibly brief, centuries-long window of its closest approach to the Sun, right when our telescopes were looking. Think about the deeply unsettling implication of that. If their survey had been conducted a few thousand years earlier, or a few thousand years later, the Goblin would have been invisible. For every object like the Goblin or Sedna that we catch brief observable, hundreds, thousands, maybe tens of thousands of others, currently hiding at the far ends of their orbits, swallowed by the dark. The objects we've detected aren't the population. They are the rounding error. Dynamical models suggest that these detached objects are just the tip of the iceberg. They point to a hidden population, an inner Oort cloud that bridges the vast gap between the scattered disk and the outer dark. This hidden census of frozen bodies could number in the tens of millions. Enormous worlds, dwarf planets, and icy debris circling us in the dark, on orbits so incredibly large that most of them will never be observed by human eyes. And yet, even these detached, ghost-like worlds are still just the suburbs. The real terror begins when the light finally gives out. Beyond the Goblin, beyond that massive dark gap, the light finally fails entirely. Welcome to the Oort Cloud. It is the largest structure associated with our Sun. But here is the most unsettling fact about it. No human telescope has ever taken a picture of a confirmed object actually sitting in the Oort Cloud. Not a single one. No spacecraft has visited it. No camera has mapped its population. In every conventional observational sense, the Oort Cloud is completely invisible. The objects out there are simply too small, too cold, and impossibly far away to reflect enough sunlight to reach our lenses. So how do astronomers know it is there? They aren't guessing. They know it in the exact same way a detective knows a crime happened even without a witness. They follow the evidence. We know the cloud is there, not because we can see it, but because we see the rain that falls from it. For thousands of years, humans have watched comets blaze across the sky. Short-period comets, like Halley's Comet, return predictably every few decades. We know they come from the Kuiper Belt. But then there are the others, the long-period comets. These are ghosts that appear entirely without warning, They fall into the inner solar system on massive, looping trajectories, get cooked by the sun, trail brilliant tails of sublimating ice, and then get slung back out into the dark. Some take hundreds of years to complete an orbit. Others take millions. In 1950, a Dutch astronomer named Jan Oort looked closely at the orbits of these long-period visitors. He noticed a pattern that broke every existing rule of the solar system. First, unlike the planets and short-period comets that orbit on a flat plane, these long-period comets came from everywhere. Above, below, behind, ahead. They fell toward the sun from every conceivable angle, in a full 360 degrees. Second, when Oort ran the math backward, tracing their trajectories to find out where they had been before falling inward, they all clustered at a specific, staggering distance. Comet after comet reached its farthest point, at roughly 50,000 astronomical units from the sun. The conclusion was inescapable. There wasn't just a flat disk of debris out there. The entire solar system was encased in a massive, spherical shell of frozen material. 1 trillion icy bodies, drifting slowly in the absolute freezing dark, waiting for a gravitational nudge to send them falling inward. Astronomers now divide this invisible empire into 2 regions. The outer Oort Cloud is a vast, sparse sphere reaching out to 100,000 astronomical units. The inner Oort Cloud, sometimes called the Hills Cloud, is flatter, denser, and acts as a massive reservoir that constantly feeds new objects into the outer shell as older ones are lost. But where did they all come from? For a long time, the accepted answer was the chaos we talked about earlier. When Neptune plowed through the early solar system, it flung all these icy bodies out into the dark. But there was a glaring mathematical problem with that theory. When scientists ran computer simulations of Neptune scattering debris, the math didn't add up. Our giant planet simply could not have thrown enough material outward to populate an Oort cloud of this massive size. There were far too many comets, and not enough raw material in our original planetary disk to make them all. Something was missing. In 2010, a team led by planetary scientist Hal Leveson published a paper that proposed an answer so wild it completely rewrote our relationship with the galaxy. Our sun was not born in isolation. It was born in a stellar nursery, a dense, crowded cluster of hundreds, maybe thousands, of sibling stars. Every single one of those stars was forming its own planets, and every single one was violently scattering its own icy debris out into space. In that chaotic, crowded environment, the gravitational reach of neighboring stars overlapped. Leveson's simulation showed that our young sun, being relatively massive, acted like a gravitational bully. It reached out into the void and actively captured the scattered debris from its neighbors. The math suggests that the sun stole them. In fact, up to 90% of the comets in the Oort cloud might not have formed around our sun at all. They formed around alien stars, stars that have long since drifted away, scattering across the Milky Way, never to be seen again. Think about what that means. The Oort cloud is not just the graveyard of our own solar system. It is a cosmic archive, a shared inheritance. When you look up and see a long-period comet streaking across the night sky, you are likely not looking at a piece of our own history. You are looking at a frozen fragment of an alien solar system, delivered to our doorstep by Identify, from a birth cluster that dissolved billions of years before the Earth even cooled. There is a kind of distance that the human brain simply refuses to process. It's not because the math is too complicated. It's because our neural architecture was built for distances we can walk. We understand the span of a valley or the horizon over an ocean. Nothing in our evolutionary history prepared us for what the Oort cloud demands. So, let's take it slowly. Let's start with what we know and walk outward until the numbers stop cooperating. Earth is 1 astronomical unit from the sun. Light takes 8 minutes to cross that gap. Neptune is at 30 astronomical units. Sunlight takes 4 hours to reach it. And out there, The sun is just a violently bright point in the sky. Now, step out to 2,000 astronomical units, the absolute closest edge of the inner Oort cloud. Out here, light from the sun is 12 days old by the time it hits you. But the sun is still unmistakably yours. It shines brighter than the thinnest crescent moon, a searing point of light that commands the sky. It still feels like home. Walk out to 20,000 astronomical units. You are now crossing the boundary between the inner and outer Oort cloud. The sun has faded. It is now only about as bright as Venus appears from Earth. It's still the brightest thing in the sky, but for the first time it has lost its absolute authority. Sunlight takes roughly 4 months to reach you. The photons hitting your face left the sun before the current season on Earth even began. Push out to 50,000 astronomical units. The sun is no longer dramatically dominant. It is just first among near equals. If you didn't know which star to look at, you might get confused. Stars like Sirius are beginning to rival it in brightness. And then, step to the absolute edge, 100,000 astronomical units. You are now 1.5 light years away from the star that birthed you. Oh, you are more than a third of the way to the Alpha Centauri star system. Out here, the sun is barely brighter than Sirius. The difference is so completely imperceptible to the human eye that, without a star chart, without exact coordinates, you would not be able to tell which of the bright points of light overhead was the one you came from. One of them is your star, the others are strangers. They look identical. You are gravitationally bound to a star that has stopped looking special. And the gravity holding you there, it's not a command anymore. It is a whisper. Solar gravity at this distance is billions of times weaker than it is on Earth. If you were an icy body drifting out here, it would take you 11 million years to complete a single orbit around the sun. 11 million years. The last time you were in this exact spot of your orbit, there were no humans. The Mediterranean Sea had dried up and refilled. By the time you return to this spot 11 million years from now, complex life on Earth might not even exist. You might think that because there are 1 trillion objects out here, the Oort cloud is crowded. It is not. It is a monument to nothingness. If you took all 1 trillion comets and spread them across this unimaginably massive spherical shell, each object would be separated from its nearest neighbor by billions of kilometers. The distance between you and the closest rock is roughly the same as the distance from the Earth to Neptune. Every frozen body drifts in its own private void. It has no neighbor. It has no sunlight worth mentioning. It is warmed only by the faint, residual microwave glow of the Big Bang itself, hovering at roughly 2.7 Kelvin. That is colder than the darkest, deepest craters on the moon. It is as cold as empty space itself. Nothing happens to these objects. No weather, no geology, no friction. They just exist, following a slow 11 million year arc through absolute silence. A perfect fossil, frozen in the exact chemical state it was in 4.5 billion years ago. If it were conscious, it would experience absolutely no stimulus for millions of years at a stretch. Until one day, something pulls on it. But what could possibly pull on a frozen rock halfway to the next star? To answer that, we have to understand that gravity has infinite range. It weakens with distance, falling off dramatically, but it never truly reaches zero. At 100,000 astronomical units, the sun's pull is tens of billions of times weaker than it is here on Earth. It is a fragile, fading thread. What changes out there in the deep dark is not whether the sun pulls, but whether something else pulls harder. And that is where the Oort cloud meets the Milky Way. The galaxy is not a passive backdrop. It is a massive, swirling gravitational beast. As the sun orbits the galactic center, the galaxy itself pulls on the solar system. This differential pull is called the galactic tide. It works subtly. It doesn't rip objects away in dramatic, violent bursts. Instead, it applies a slow, steady torque over millions of years, rotating the orbital planes of these distant Oort Cloud objects. Eventually, the tide shifts a comet's orbit just enough that it begins to fall inward. This patient, relentless galactic tide is the dominant force stripping icy bodies from the Oort Cloud and sending them toward the sun. But the tide is not the only force out there. There are also the invaders. Stars move. As our sun travels through the Milky Way, it occasionally passes close to other stars. Most of the time, they are light years apart. But once in a very long while, a star drifts close enough to carve a path directly through the Oort Cloud itself. Roughly 70,000 years ago, a small binary system called Schultz's star passed within roughly 52 zeros and astronomical units of the Sun. That placed it deep inside the outer Oort Cloud. Think about that moment on Earth. Homo sapiens were sharing the planet with Neanderthals. Our ancestors sat around campfires, looking up at the exact same Milky Way we see today, telling stories about the constellations. They had no concept of a solar system. They had no idea that far above their heads, totally invisible to the naked eye, a dim red dwarf star was drifting right through the outermost edges of the Sun's territory. Schultz's star came. It tugged on millions of icy bodies, and it left. But in the Oort Cloud, tiny perturbations compound over millions of years. Comets that were nudged by that passing star 70,000 years ago are falling toward us right now. They are drifting through the vast space between the Oort Cloud and the planets, and they will not arrive for thousands or millions of years. When they do, they will appear in Earth's sky as brilliant new comets, and no one will know that their journey began because a red dwarf brushed past us before the dawn of human civilization, and it will happen again. Data from the Gaia spacecraft confirms that a star named Gliese 710 is heading our way. In about 1.3 million years, it will pass incredibly close, perhaps just 13 astronomical units from the Sun. It will plow directly through the dense, populated regions of the inner Oort Cloud. The gravitational shockwave of that encounter will send a massive delayed shower of comets raining down into the inner solar system. The Oort Cloud is not a closed vault. It is a living, breathing system, constantly stirred by the galaxy. And because it is so open, it is not strictly ours. In 2017, astronomers detected a strange, cigar-shaped object tumbling through our solar system at blistering speed. It was named Oumuamua. 2 years later, a second object, a highly active comet named Borisov, was discovered on a similar, impossible trajectory. These were not from the Oort Cloud. They were interstellar visitors. Alien comets, ejected from distant, unknown star systems, drifting through the Milky Way until they happened to plunge through our neighborhood. The detection of Oumuamua and Borisov changes everything we thought we knew about the empty space at the edge of our solar system. It means the Oort Cloud is porous. At any given moment, there are likely trillions of alien, interstellar objects drifting through the exact same space that our Oort Cloud occupies. The space between the stars is a shared gravitational commons, a vast, dark ocean where debris from a dozen different stellar systems mixes, drifts, and passes through without allegiance. The boundary between what belongs to our Sun and what belongs to the galaxy is entirely an illusion. The region where the Sun's gravitational dominance and finally gives way to the galaxy is described by a concept called the Hill sphere. But it is not a fixed fence. It is a gradient. When the Sun passes through a denser region of the Milky Way, the Hill sphere contracts. When it moves into a less dense region, the sphere expands. The outer boundary of our solar system literally breathes, shifting by thousands of astronomical units over the course of a single galactic orbit. There is no fixed edge. The border of our home is a moving target, defined only by a temporary gravitational truce between our Sun and the Milky Way. And eventually, the Sun is going to lose that truce. In roughly 5 billion years, Our sun will exhaust the hydrogen fuel in its core. It will swell into a red giant engulfing Mercury, Venus, and likely Earth. But the more significant effect for the Oort cloud won't be the heat, it will be the mass loss. As the sun expands, it will shed enormous quantities of material through powerful stellar winds, losing roughly half of its current mass. Gravity depends on mass. Halve the sun's mass, and you halve its gravitational pull. The Hill sphere will contract dramatically. The outermost objects of the Oort cloud, trillions of icy bodies that have orbited the sun for 4.5 billion years, will find themselves no longer held. They will gradually slip away. Their orbits will widen past the point of no return, drifting outward into interstellar space with absolutely no force left to bring them back. The Oort cloud will dissolve. Slowly, over hundreds of millions of years, the sun's shrinking gravitational authority will release its most distant possessions into the galaxy. They will become orphaned debris. They will become someone else's interstellar visitor vicis, fossils from a dead star's youth, carrying the chemical fingerprints of a planetary disk that formed 10 billion years before their arrival. The solar system doesn't just fade at its edges in space. It will eventually fade in time. We are accustomed to thinking of the solar system as a specific place, a location with a defined shape and a clear border. That textbook diagram we talked about at the beginning reinforces this comforting intuition. Inside the boundary is our home, outside is everything else. The Oort cloud destroys this picture entirely. There is no clean border. The solar system does not end, it dissolves. The boundary between what belongs to the sun and what belongs to the galaxy is a fog. It's a gradient of ink spreading on wet paper, thinning outward until the edge is nowhere and everywhere at the same time. The planets are where the sun's story is loudest. The Oort cloud is where it becomes a murmur, and somewhere past the outer cloud, that murmur fades to absolutely nothing. Out there, you are no longer in the solar system because you are no longer anywhere specific. You are in the space between stars. The shared gravitational commons, where no single sun dominates, where the concept of belonging to a particular star loses all definition. The solar system you grew up imagining was a convenient fiction. The real solar system is darker, colder, emptier, and far more enormous than any illustration could ever convey. It stretches outward for more than a light year. It contains more frozen worlds than you could count in a lifetime. And it has no wall, no line in the dark where you can stand and say, "Here, the sun's kingdom ends." It just fades. And that fading is the most honest, beautiful, and terrifying thing about it. Because the universe doesn't draw borders. It draws gradients. And we live inside one, warmed by a star whose reach extends far beyond its light, drifting through a galaxy that treats our sun as just another point of gravity in an ocean of stars. The solar system never really ends. It just stops mattering. Right now, the farthest human-made object ever built is drifting through space at over 60,000 kilometers per hour. Voyager 1 has been flying for nearly 50 years. It has crossed the edge of the solar wind, punched through the boundary where our sun's breath fades to nothing, and entered interstellar space. It is roughly 170 astronomical units from home, and it has not even begun to reach the Oort cloud. The inner edge of that invisible shell sits more than 2,000 astronomical units away. The outer edge might stretch past 100,000. If Voyager 1 were a car pulling out of your driveway, it hasn't yet reached the end of your street. And the Oort cloud is on another continent. If you enjoy journeys that stretch the mind past anything comfortable, do me a small favor and hit that like button. And if you haven't already, subscribe so you don't miss what comes next. Now, get yourself comfortable. Let's begin. Open any astronomy textbook. Find the diagram of the solar system. There it is. A clean illustration with 8 planets arranged in neat concentric orbits around a yellow star. Mercury closest, then Venus, Earth, Mars. A stippled band for the asteroid belt. Jupiter, Saturn, Uranus, Neptune. Maybe Pluto appears as a small dot at the far edge with a dashed orbit, and a footnote explaining its reclassification. The whole arrangement fits perfectly on a single page. The labels are tidy. The distances look manageable. You can trace the entire solar system with your fingertip in about 2 seconds. That diagram is a lie. It's not just slightly off. It's not just rounded up for convenience. It is wrong by a factor so extreme that calling it an oversimplification doesn't even come close. If you corrected that classroom image to true scale, the 8 planets would collapse into a space so small you couldn't print it. The entire zone from Mercury out to Neptune, every world you have ever been taught about, every rocky surface, every gas giant, every ring system, every moon, occupies less than 0.1% of the Sun's actual gravitational territory. Everything beyond that thin planetary ribbon belongs to a solar system you were never shown. A solar system that is darker, emptier, and so vast that the familiar planetary neighborhood shrinks to a pinprick at the center of something almost incomprehensibly large. Let's start with what we know for certain. Neptune orbits the Sun at an average distance of about 30 astronomical units. 1 astronomical unit, or AU, is the distance from Earth to the Sun, roughly 150 million kilometers. So, Neptune sits 30 times farther from the Sun than Earth does. That distance is impressive by everyday standards. Light from the Sun takes about 4 hours to reach Neptune. A spacecraft traveling at Voyager's blistering speed would need over 12 years just to arrive. For most of human history, Neptune marked the outermost boundary of the known solar system. And honestly, that seemed like enough. When astronomers discovered Neptune in 1846, they believed they had found the frontier. For over a century afterward, the map expanded only slightly with the discovery of Pluto in 1930. Pluto sat at the edge of the map, a tiny frozen dot, and for a long time, humanity assumed the solar system ended right there. Except it didn't. The planetary solar system is not the actual solar system. It is just the brightly lit lobby of an unimaginably vast, dark building. And to understand what lies beyond that lobby, we have to look at the wreckage left behind. To understand the scale of what we are dealing with, we have to look at the first layer of that wreckage, the immediate suburbs. For decades, Pluto was the ultimate misfit. It had a weird tilted orbit. It crossed Neptune's path. It was tiny, smaller than our own moon. It simply didn't belong with the majestic gas giants. Back in the 1950s, astronomer Gerard Kuiper suggested that maybe Pluto wasn't an anomaly at all. Maybe it was just the brightest, most visible object in a massive belt of frozen debris left over from the formation of the planets. It took 40 years of technological advancement to prove him right. In 1992, astronomers finally spotted another dim object beyond Neptune, then another, then hundreds more. This avalanche of discoveries revealed the Kuiper Belt, a massive, donut-shaped ring of icy bodies stretching from 30 to 50 astronomical units from the Sun. When NASA's New Horizons spacecraft finally reached Pluto in 2015, it silenced anyone who thought the outer solar system was boring. It didn't find a dead, cratered rock. It found a complex, geologically active world. There were flowing nitrogen glaciers, towering mountains of solid water ice, rising as high as the Rockies on Earth. A blue, hazy atmosphere backlit by the distant sun. 4 years later, the probe flew past Arakoth, a pristine, reddish, snowman-shaped rock that has sat in a cosmic deep freeze, entirely undisturbed for 4.5 billion years. But the Kuiper Belt is just the front porch. And it doesn't end with a clean boundary. It frays outward into something far more violent. To understand why, you have to realize that the orderly, clockwork solar system you see today is an illusion. It is the aftermath of a catastrophe. In its infancy, the solar system was packed tightly. Jupiter, Saturn, Uranus, and Neptune orbited much closer to the Sun than they do now, surrounded by a dense, heavy disk of icy debris. For millions of years, this arrangement was relatively stable. Then, Jupiter and Saturn hit a gravitational tripwire. They crossed an orbital resonance, meaning every time Saturn completed one orbit, massive Jupiter completed exactly two. Their combined gravity pulsed in rhythm, pumping enormous, destabilizing energy into the outer solar system. The whole structure broke down. In a geologically brief window, the giant planets scattered like billiard balls. Saturn pushed outward. Uranus and Neptune were hurled into wider orbits. Neptune, massive and unstoppable, plowed directly into that pristine ring of icy debris, like a wrecking ball into a brick wall. The gravitational violence of that moment is hard to overstate. Neptune swept through trillions of frozen objects, grabbing them with its gravity and hurling them in every direction. Some were thrown inward, causing a devastating meteor bombardment that scarred the early Earth and Moon. Countless others were ejected from the solar system entirely, banished to the interstellar void. But a massive fraction of that debris was thrown outward onto wild, elongated, highly tilted orbits. These barely bound survivors carry the permanent, chaotic signature of that ancient disaster. We call this region the scattered disk. The scattered disk overlaps with the outer edges of the Kuiper belt, but it pushes the frontier much, much farther. The most extreme objects in this scattered population have orbits that carry them hundreds of astronomical units from the Sun. That alone is enough to shatter the textbook map. We are already talking about distances tens of times farther than Pluto. But the true shock isn't the suburbs. It is what happens after the suburbs end. Because beyond the scattered disk, there is a gap, a vast, dark, seemingly empty chasm between the known worlds and whatever lies waiting in the dark. Let's talk about that gap, from roughly 1,000 astronomical units out to perhaps 2,000 or more. There is a desert. No confirmed objects populate it. No telescope has surveyed it comprehensively. It is a staggering chasm between the outer fringes of the scattered disk and the beginning of the Oort Cloud. Try to picture what this gap contains. Nothing that we know of. No icy bodies large enough to detect. No scattered debris returning from distant orbits. Just space. Cold, empty, featureless space, stretching outward for hundreds of billions of kilometers without a single landmark. Out here, the Sun has entirely lost the appearance of a disk. It is just a point of light. Brilliant. Yes, but small. It offers absolutely no warmth and precious little illumination. An object drifting through this gap would be bathed in near total darkness, lit only by starlight and the faint residual microwave glow of the Big Bang itself. At Voyager 1's blistering speed, crossing this gap alone would take centuries. But it's what astronomers found just before and inside the edges of this gap that truly broke the models. In 2003, astronomers Michael Brown, Chad Trujillo, and David Rabinowitz discovered a distant object that defied every existing category. They named it Sedna, after the Inuit goddess of the sea. Sedna's orbit was unlike anything ever observed. Its perihelion, the closest it ever comes to the Sun, is approximately 76 astronomical units. Why is that a big deal? Because Neptune orbits at 30 astronomical units. Even the most extreme scattered disk objects pass close enough to Neptune during part of their orbits to feel its gravitational pull. Sedna does not. It is gravitationally detached from every known planet. Neptune cannot touch it. At the same time, Sedna swings out to nearly 1,000 astronomical units, placing it in a strange orbital no man's land. It is too distant to be part of the scattered disk, but too close to the Sun to belong to the classical Oort Cloud. Sedna shouldn't exist where it does. Nothing could have formed out there, and no known planet could have pushed it there. And Sedna is not alone. In 2014, astronomers found 2012 VP-113, another detached object with an orbit totally isolated from the giant planets. Then, in 2018, came the discovery of 2015 TG-387, informally nicknamed the Goblin. The Goblin is a ghost of a world. Its closest approach sits at 65 astronomical units, but its orbit stretches out past 1,100 astronomical units. It takes roughly 40,000 years for the Goblin to complete a single orbit around the Sun. For the overwhelming majority of that time, it drifts in total darkness, so far beyond the reach of human telescopes that it is entirely invisible. It spends almost its entire existence as an undetectable phantom. Astronomers only found the Goblin because it happened to be passing through that incredibly brief, centuries-long window of its closest approach to the Sun, right when our telescopes were looking. Think about the deeply unsettling implication of that. If their survey had been conducted a few thousand years earlier, or a few thousand years later, the Goblin would have been invisible. For every object like the Goblin or Sedna that we catch brief observable are hundreds, thousands, maybe tens of thousands of others, currently hiding at the far ends of their orbits, swallowed by the dark. The objects we've detected aren't the population. They are the rounding error. Dynamical models suggest that these detached objects are just the tip of the iceberg. They point to a hidden population, an inner Oort cloud that bridges the vast gap between the scattered disk and the outer dark. This hidden census of frozen bodies could number in the tens of millions. Enormous worlds, dwarf planets, and icy debris circling us in the dark, on orbits so incredibly large that most of them will never be observed by human eyes. And yet, even these detached, ghost-like worlds are still just the suburbs. The real terror begins when the light finally gives out. Beyond the Goblin, beyond that massive dark gap, the light finally fails entirely. Welcome to the Oort Cloud. It is the largest structure associated with our Sun. But here is the most unsettling fact about it. No human telescope has ever taken a picture of a confirmed object actually sitting in the Oort Cloud. Not a single one. No spacecraft has visited it. No camera has mapped its population. In every conventional observational sense, the Oort Cloud is completely invisible. The objects out there are simply too small, too cold, and impossibly far away to reflect enough sunlight to reach our lenses. So how do astronomers know it is there? They aren't guessing. They know it in the exact same way a detective knows a crime happened even without a witness. They follow the evidence. We know the cloud is there, not because we can see it, but because we see the rain that falls from it. For thousands of years, humans have watched comets blaze across the sky. Short-period comets, like Halley's Comet, return predictably every few decades. We know they come from the Kuiper Belt. But then there are the others, the long-period comets. These are ghosts that appear entirely without warning. They fall into the inner solar system on massive, looping trajectories, get cooked by the sun, trail brilliant tails of sublimating ice, and then get slung back out into the dark. Some take hundreds of years to complete an orbit. Others take millions. In 1950, a Dutch astronomer named Jan Oort looked closely at the orbits of these long-period visitors. He noticed a pattern that broke every existing rule of the solar system. First, unlike the planets and short-period comets that orbit on a flat plane, these long-period comets came from everywhere. Above, below, behind, ahead. They fell toward the sun from every conceivable angle, in a full 360 degrees. Second, when Oort ran the math backward, tracing their trajectories to find out where they had been before falling inward, they all clustered at a specific, staggering distance. Comet after comet reached its farthest point, at roughly 50,000 astronomical units from the sun. The conclusion was inescapable. There wasn't just a flat disk of debris out there. The entire solar system was encased in a massive, spherical shell of frozen material. 1 trillion icy bodies, drifting slowly in the absolute freezing dark, waiting for a gravitational nudge to send them falling inward. Astronomers now divide this invisible empire into 2 regions. The outer Oort Cloud is a vast, sparse sphere reaching out to 100,000 astronomical units. The inner Oort Cloud, sometimes called the Hills Cloud, is flatter, denser, and acts as a massive reservoir that constantly feeds new objects into the outer shell as older ones are lost. But where did they all come from? For a long time, the accepted answer was the chaos we talked about earlier. When Neptune ploughed through the early solar system, it flung all these icy bodies out into the dark. But there was a glaring mathematical problem with that theory. When scientists ran computer simulations of Neptune scattering debris, the math didn't add up. Our giant planet simply could not have thrown enough material outward to populate an Oort cloud of this massive size. There were far too many comets, and not enough raw material in our original planetary disk to make them all. Something was missing. In 2010, a team led by planetary scientist Hal Leveson published a paper that proposed an answer so wild it completely rewrote our relationship with the galaxy. Our sun was not born in isolation. It was born in a stellar nursery, a dense, crowded cluster of hundreds, maybe thousands, of sibling stars. Every single one of those stars was forming its own planets, and every single one was violently scattering its own icy debris out into space. In that chaotic, crowded environment, the gravitational reach of neighboring stars overlapped. Leveson's simulation showed that our young sun, being relatively massive, acted like a gravitational bully. It reached out into the void and actively captured the scattered debris from its neighbors. The math suggests that the sun stole them. In fact, up to 90% of the comets in the Oort cloud might not have formed around our sun at all. They formed around alien stars, stars that have long since drifted away, scattering across the Milky Way, never to be seen again. Think about what that means. The Oort cloud is not just the graveyard of our own solar system. It is a cosmic archive, a shared inheritance. When you look up and see a long-period comet streaking across the night sky, you are likely not looking at a piece of our own history. You are looking at a frozen fragment of an alien solar system, delivered to our doorstep by Identify, from a birth cluster that dissolved billions of years before the Earth even cooled. There is a kind of distance that the human brain simply refuses to process. It's not because the math is too complicated. It's because our neural architecture was built for distances we can walk. We understand the span of a valley or the horizon over an ocean. Nothing in our evolutionary history prepared us for what the Oort cloud demands. So, let's take it slowly. Let's start with what we know and walk outward until the numbers stop cooperating. Earth is 1 astronomical unit from the sun. Light takes 8 minutes to cross that gap. Neptune is at 30 astronomical units. Sunlight takes 4 hours to reach it. And out there, the sun is just a violently bright point in the sky. Now, step out to 2,000 astronomical units, the absolute closest edge of the inner Oort cloud. Out here, light from the sun is 12 days old by the time it hits you. But the sun is still unmistakably yours. It shines brighter than the thinnest crescent moon, a searing point of light that commands the sky. It still feels like home. Walk out to 20,000 astronomical units. You are now crossing the boundary between the inner and outer Oort cloud. The sun has faded. It is now only about as bright as Venus appears from Earth. It's still the brightest thing in the sky, but for the first time it has lost its absolute authority. Sunlight takes roughly 4 months to reach you. The photons hitting your face left the sun before the current season on Earth even began. Push out to 50,000 astronomical units. The sun is no longer dramatically dominant. It is just first among near equals. If you didn't know which star to look at, you might get confused. Stars like Sirius are beginning to rival it in brightness. And then Step to the absolute edge, 100,000 astronomical units. You are now 1.5 light years away from the star that birthed you. Oh. You are more than a third of the way to the Alpha Centauri star system. Out here, the sun is barely brighter than Sirius. The difference is so completely imperceptible to the human eye that, without a star chart, without exact coordinates, you would not be able to tell which of the bright points of light overhead was the one you came from. One of them is your star, the others are strangers. They look identical. You are gravitationally bound to a star that has stopped looking special. And the gravity holding you there, it's not a command anymore. It is a whisper. Solar gravity at this distance is billions of times weaker than it is on Earth. If you were an icy body drifting out here, it would take you 11 million years to complete a single orbit around the sun. 11 million years. The last time you were in this exact spot of your orbit, there were no humans. The Mediterranean Sea had dried up and refilled. By the time you return to this spot 11 million years from now, complex life on Earth might not even exist. You might think that because there are 1 trillion objects out here, the Oort Cloud is crowded. It is not. It is a monument to nothingness. If you took all 1 trillion comets and spread them across this unimaginably massive spherical shell, each object would be separated from its nearest neighbor by billions of kilometers. The distance between you and the closest rock is roughly the same as the distance from the Earth to Neptune. Every frozen body drifts in its own private void. It has no neighbor. It has no sunlight worth mentioning. It is warmed only by the faint, residual microwave glow of the Big Bang itself, hovering at roughly 2.7 Kelvin. That is colder than the darkest, deepest craters on the moon. It is as cold as empty space itself. Nothing happens to these objects. No weather, no geology, no friction. They just exist, following a slow 11 million year arc through absolute silence. A perfect fossil, frozen in the exact chemical state it was in 4.5 billion years ago. If it were conscious, it would experience absolutely no stimulus for millions of years at a stretch. Until one day, something pulls on it. But what could possibly pull on a frozen rock halfway to the next star? To answer that, we have to understand that gravity has infinite range. It weakens with distance, falling off dramatically, but it never truly reaches zero. At 100,000 astronomical units, the sun's pull is tens of billions of times weaker than it is here on Earth. It is a fragile, fading thread. What changes out there in the deep dark is not whether the sun pulls, but whether something else pulls harder. And that is where the Oort Cloud meets the Milky Way. The galaxy is not a passive backdrop. It is a massive, swirling gravitational beast. As the sun orbits the galactic center, the galaxy itself pulls on the solar system. This differential pull is called the galactic tide. It works subtly. It doesn't rip objects away in dramatic, violent bursts. Instead, it applies a slow, steady torque over millions of years, rotating the orbital planes of these distant Oort Cloud objects. Eventually, the tide shifts a comet's orbit just enough that it begins to fall inward. This patient, relentless galactic tide is the dominant force stripping icy bodies from the Oort Cloud and sending them toward the sun. But the tide is not the only force out there. There are also the invaders. Stars move. As our sun travels through the Milky Way, it occasionally passes close to other stars. Most of the time, they are light years apart. But once in a very long while, a star drifts close enough to carve a path directly through the Oort Cloud itself. Roughly 70,000 years ago, a small binary system called Schultz's star passed within roughly 52 zeros and astronomical units of the sun. That placed it deep inside the outer Oort Cloud. Think about that moment on Earth. Homo sapiens were sharing the planet with Neanderthals. Our ancestors sat around campfires, looking up at the exact same Milky Way we see today, telling stories about the constellations. They had no concept of a solar system. They had no idea that far above their heads, totally invisible to the naked eye, a dim red dwarf star was drifting right through the outermost edges of the sun's territory. Schultz's star came. It tugged on millions of icy bodies, and it left. But in the Oort cloud, tiny perturbations compound over millions of years. Comets that were nudged by that passing star 70,000 years ago are falling toward us right now. They are drifting through the vast space between the Oort cloud and the planets, and they will not arrive for thousands or millions of years. When they do, they will appear in Earth's sky as brilliant new comets, and no one will know that their journey began because a red dwarf brushed past us before the dawn of human civilization, and it will happen again. Data from the Gaia spacecraft confirms that a star named Gliese 710 is heading our way. In about 1.3 million years, it will pass incredibly close, perhaps just 13 astronomical units from the Sun. It will plow directly through the dense, populated regions of the inner Oort cloud. The gravitational shockwave of that encounter will send a massive, delayed shower of comets raining down into the inner solar system. The Oort cloud is not a closed vault. It is a living, breathing system, constantly stirred by the galaxy. And because it is so open, it is not strictly ours. In 2017, astronomers detected a strange, cigar-shaped object tumbling through our solar system at blistering speed. It was named Oumuamua. 2 years later, a second object, a highly active comet named Borisov, was discovered on a similar, impossible trajectory. These were not from the Oort cloud. They were interstellar visitors. Alien comets, ejected from distant, unknown star systems, drifting through the Milky Way until they happened to plunge through our neighborhood. The detection of Oumuamua and Borisov changes everything we thought we knew about the empty space at the edge of our solar system. It means the Oort cloud is porous. At any given moment, there are likely trillions of alien, interstellar objects drifting through the exact same space that our Oort cloud occupies. The space between the stars is a shared gravitational commons, a vast, dark ocean where debris from a dozen different stellar systems mixes, drifts, and passes through without allegiance. The boundary between what belongs to our sun and what belongs to the galaxy is entirely an illusion. The region where the sun's gravitational dominance and finally gives way to the galaxy is described by a concept called the Hill sphere. But it is not a fixed fence. It is a gradient. When the sun passes through a denser region of the Milky Way, the Hill sphere contracts. When it moves into a less dense region, the sphere expands. The outer boundary of our solar system literally breathes, shifting by thousands of astronomical units over the course of a single galactic orbit. There is no fixed edge. The border of our home is a moving target, defined only by a temporary gravitational truce between our sun and the Milky Way, and eventually, the sun is going to lose that truce. In roughly 5 billion years, our sun will exhaust the hydrogen fuel in its core. It will swell into a red giant engulfing Mercury, Venus, and likely Earth. But the more significant effect for the Oort cloud won't be the heat, it will be the mass loss. As the sun expands, it will shed enormous quantities of material through powerful stellar winds, losing roughly half of its current mass. Gravity depends on mass. Halve the sun's mass, and you halve its gravitational pull. The Hill sphere will contract dramatically. The outermost objects of the Oort cloud, trillions of icy bodies that have orbited the sun for 4.5 billion years, will find themselves no longer held. They will gradually slip away. Their orbits will widen past the point of no return, drifting outward into interstellar space with absolutely no force left to bring them back. The Oort cloud will dissolve. Slowly, over hundreds of millions of years, the sun's shrinking gravitational authority will release its most distant possessions into the galaxy. They will become orphaned debris. They will become someone else's interstellar visitor, Visis. fossils from a dead star's youth, carrying the chemical fingerprints of a planetary disk that formed 10 billion years before their arrival. The solar system doesn't just fade at its edges in space, it will eventually fade in time. We are accustomed to thinking of the solar system as a specific place, a location with a defined shape and a clear border. That textbook diagram we talked about at the beginning reinforces this comforting intuition. Inside the boundary is our home, outside is everything else. The Oort Cloud destroys this picture entirely. There is no clean border. The solar system does not end, it dissolves. The boundary between what belongs to the sun and what belongs to the galaxy is a fog. It's a gradient of ink spreading on wet paper, thinning outward until the edge is nowhere and everywhere at the same time. The planets are where the sun's story is loudest. The Oort Cloud is where it becomes a murmur, and somewhere past the outer cloud, that murmur fades to absolutely nothing. Out there, you are no longer in the solar system because you are no longer anywhere specific. You are in the space between stars. The shared gravitational commons, where no single sun dominates, where the concept of belonging to a particular star loses all definition. The solar system you grew up imagining was a convenient fiction. The real solar system is darker, colder, emptier, and far more enormous than any illustration could ever convey. It stretches outward for more than a light year. It contains more frozen worlds than you could count in a lifetime. And it has no wall, no line in the dark where you can stand and say, "Here, the sun's kingdom ends." It just fades. And that fading is the most honest, beautiful, and terrifying thing about it. Because the universe doesn't draw borders, it draws gradients. And we live inside one, warmed by a star whose reach extends far beyond its light, drifting through a galaxy that treats our sun as just another point of gravity in an ocean of stars. The solar system never really ends. It just stops mattering.